Okay, time to talk about vectors. Now, a vector is a directed line segment, like this one. Notice it has a starting point. We call this the initial point. Here I've labeled this point P, and it's at the coordinate 2, 4. And then it has an ending point where it stops. I labeled that point Q, and that's the point 5, 8. Now, because this has an initial point of P and a terminal point of Q, sometimes we'll label that vector PQ, like this, and put a little arrow above it to indicate that it's a vector. Some other times, maybe we won't put the arrow above it. We'll just represent the vector as a boldface, PQ. But anyway, this is the vector. Now, with vectors, what we're concerned about is not necessarily where they start and stop, but the direction of the vector, which way is it pointing, and also the length of the vector. We call that the magnitude. So as long as we can talk about the direction of the vector and the magnitude of the vector, we don't really care where it starts. It might be simpler though if we could start it at the origin. So let's do that. Let's just take this vector and subtract 2 from, just move everything over 2 units. That's like taking the 5 component from the terminal point, and subtracting the 2 from the initial point. So notice 5 minus 2. That moves every point over 2 units to the left. Now we want to take 8 minus 4. In other words, shift everything down 4 units. Now, what we've done is we've not changed the magnitude or the direction of the vector. We've simply scooted it over, and now we have the vector ending having a terminal point of 3, 4. So it has an initial point of 0, 0 and a terminal point of 3, 4. And now we might want to name this vector something like V. And just instead of having the initial and terminal point, we just have the terminal point, and we designate that vector to be 3, 4. And notice these little brackets that we have here. This is the way when you see that, you know you're talking about a vector. Okay, so this vector, it's understood to start at the origin, and this is the terminal point here. Okay, now I want to talk about the magnitude of the vector. The magnitude is simply the length. And it's always positive. Now notice this magnitude I get just by taking the square root of the 3 squared plus the 4 squared, squaring both of those, adding them, and then taking the square root. And notice that's just Pythagorean theorem. See, so what we have here is we have the x, I square that, a squared plus b squared equals c squared. See, the magnitude. So there you have it. There's the magnitude, which is like the hypotenuse of that, and it is the hypotenuse of that right triangle. Okay, so that's one of the things that we want to be able to do when we're given a vector. Well, 2 things. We want to be able to take a vector that's defined with an initial point and a terminal point and put it in this form right here, and we call that component form. Okay, this is component form. Then we want to be able to take that component form and find the magnitude of the vector. So we have 3 squared plus 4 squared, the square root of that is 5, and that's the magnitude. So we want to be able to put a vector in component form and find the magnitude of it. Now, we also want to be able to find the direction angle, this angle right there that I'm designating as theta. We want to be able to find that. Now notice that this 4 here, the y component, is the angle, is the side opposite theta, and the x component down here, the x component of the vector, is actually the length of the adjacent side. And of course tangent is opposite over adjacent, so that's 4 over 3. So right away we get this connection here. We have a way of relating theta and the 4 and the 3, and we do that through tangent. So tangent theta equals 4/3. That means that theta equals the inverse of tangent of 4/3. The inverse tangent of 4/3, which in this case is 53.13 approximately degrees. So we found the direction angle. Now you have to be careful when you're finding direction angles, because remember that inverse tangent will only give you values in quadrant 1 or 4. It's only going to give you values between negative 90 degrees and positive 90, not including those two. So if your vector is actually pointing in quadrant 2 or 3, you have to do something else. So let's see what you have to do. Notice that if I want to find this angle theta, I'm going to do inverse tangent of negative 4 over negative 3, which is inverse tangent of 4/3, which we already found that is approximately 53.1 degrees. Now, that's obviously not the direction of that vector. So here's what we have to do. Whenever we get a vector that's pointing in direction in quadrant 2 or 3, we have to add 180 degrees to it. So the real direction angle is 53.1 plus 180. Now, if we were in radian mode, we wouldn't add 180 degrees, of course, we would add pi.